mass and weight. Mass. The mass of an object is a measure of the quantity of matter it contains, and it is also a measure of the object's inertia. Inertia is the reluctance of a body to move or to resist motion. Then mass is measured in kilograms. So the symbol is kg. Then mass has a constant value for a particular object anywhere on Earth or in space. So mass is the same on Earth and on the Moon or anywhere in space. Now let's talk about weight. Weight of an object is a measure of the force of gravity acting on that object. Then it is measured in newtons because it's a force. Now the value can vary over the surface of the Earth, unlike mass. The value of weight can vary over the surface of Earth and will have a value reduced by a factor of 6 on the Moon. So if the force of gravity on Earth is approximately 10, then on the Moon the force of gravity will be 1/6 of 10. So let's take an example. A rectangular block weighs 500 Newton. Calculate its mass. So we know that weight is equal to mass times gravity due to acceleration. So let's assume that the gravity due to acceleration is approximately 10 meters per second. 10 meters per second squared. So this is the gravity due to acceleration. Now we're given the weight of a block to be equal to 500 newtons. 500 newtons. And we want to find the mass, so we know two quantities and we are looking for the mass, which is m. So we just have to do substitution over here. So 500, which is the weight, is equal to the mass, the quantity we are looking for, times gravity due to acceleration, which is 10. So we just have to divide both sides by 10. So this one divided by 10 and this one divided by 10. So we have the mass. So this cancels this. This goes here 50 times. Therefore the mass is equal to 50 kg. 50 kg. The mass of the block is 50 kg. What is the difference between mass and weight? So this is SSC 1996. So let's look at the differences. We have mass and we have weight. First, mass is the quantity of matter. Quantity of matter a body contains. Then weight is a measure of the force of gravity acting on that body. And mass is constant everywhere on Earth, but weight of a body varies from place to place. And the mass is measured in kilograms, whereas weight is measured in newtons. Then we have mass is a scalar quantity and weight is a vector quantity. And last but not the least, we have mass being measured by a means of beam balance, but weight is measured by means of spring balance. What is the mass of 1.5 liters of water? The mass of 1.5 liters of water is just 1.5 kg. The mass of an astronaut on Earth is 15 kg. The reason is that 1 kg of water is equal to 1 liter of water. Therefore, 1.5 kg of water, or 1.5 liters of water, will be equal to 1.5 kg of water. So back to our question. The mass of an astronaut on the Earth is 15.5 kg. Calculate the mass of this astronaut on Moon. Mass of an astronaut on the Earth is 15.5 kg. Calculate the mass of the astronaut on Moon. So this is just the concept. If you don't understand the concept of mass, this question can trick you. You have to know that mass is constant everywhere. Therefore, if the mass of an astronaut is 15 kg on Earth, then on the Moon it is still 15.5 kg. So 15.5 kg on Earth, and on the Moon it is still 15.5 kg. A lunar stone sent to the Earth by an astronaut weighed 360 Newton on Moon. So that is the weight on Moon. So let me say this is weight, and the weight on Moon is 360 newtons. 360 newtons. What will be the weight of the stone on Earth? So we know the weight of stone on Earth will be something bigger or larger than that of the weight on the Moon, because on the Moon it has been reduced by 1/6. So it has been reduced by a factor of 6. Now we need to look for the acceleration due to gravity, so we can find 1/6 of that. So weight is equal to mass times acceleration due to gravity. So if the gravity due to acceleration is 10, approximately 10, then our weight, which is equal to mass times gravity due to acceleration, should be equal to this. We need to look for the mass of the stone on the Moon, which is the same as the mass on Earth. So the mass of the stone on Moon, we need to substitute this. We have 360 is equal to mass times gravity, which is 10. So we need to divide both sides by 10. So we are solving for the mass of the stone. So 10 goes into 360 36 times. Thought I've changed ink. Then 10 cancel this. So the mass is 36 kg. So the mass is 36 kg. So the mass on the moon, the mass of the lunar stone on the moon is 36 kg. So the mass is 36 kg. The mass of the lunar stone is 36 kg. If we assume that gravity due to acceleration is 10 on the moon. Now we can't tell whether it is actually 10, but what we can do now is we know that whatever the gravity is, we multiplied whatever the gravity is on Earth, we divided by 6 and multiplied by the mass before we got the weight. We got the weight to be equal to 360 Newton on the moon. So what we have to do now is we just substitute this 360 Newton. We know that is the weight of the object on moon, so that is equal to 360 Newton. So what we are going to do right now is to solve for gravity due to acceleration. That is what was on Earth. Then we multiply it by the gravity, by the mass, which is constant. So we don't actually know the mass. So this thing work over here is when we're assuming that the gravity was 10. So gravity due to acceleration times mass will be equal to this thing times 6. It will be equal to 360 Newton times 6. So if you evaluate this, we will obtain 6 times 360 will give us 2160 newtons. But we know that gravity due to acceleration times the mass will give us the weight of the object on Earth. So weight on Earth is 2160 newtons. Hence the correct answer is option A. Last but not the least, we have this question. Which of the following quantities is a scalar? A scalar quantity is a quantity that has a magnitude, but it has no direction. So displacement has magnitude and direction. Force has magnitude and direction. Mass has only magnitude. That's why we can say something is 50 kg. 50 kg. Velocity has both magnitude and direction. So the correct answer here is mass. We've seen this earlier where we were looking at the difference between mass and weight. Mass and weight. Then one of the points was that weight is a vector quantity whereas mass is a scalar quantity. Therefore, the correct choice over here is C.